This video is going to cover probability involving the word and. So let's look at our formula. The probability of A and B is equal to the probability of A times the probability of B. Important note here, the probability of B is calculated just assuming that A already occurred. Okay, so let's look at an example. Let's say I roll a die 2 times. So not 2 separate dice, but one die, I roll it, and then I roll it again. All right, so let's find the probability that both results are 4s. Okay. So each time I roll it, I have a 1 out of 6 probability of getting a 4. So if I'm going to roll the die 2 times, I would have the probability of 1 over 6 times 1 over 6, which gives me 1 over 36. Okay, so let's roll that die again 2 times and then find the probability both results are even. Okay. So the probability of getting an even number when I roll a die is a half. There's 3 times that are even, 3 times that are odd, so it's equal, so it's 50-50. So if I'm rolling the die 2 times, I have a half that the first one will be even, a half the second will be even, which a half times a half is a fourth. Okay. Let's roll a die twice and then find the probability that I get at least 1 4. All right. So this phrase, and let's kind of underline it to say it's really important. This phrase, at least, is really going to be key when you're doing your probability work. You want to look for this phrase when it happens, maybe underline it just to draw yourself into and think, okay, what does this at least mean? So at least 1 4 means I could have 1 4. It could be the first one, it could be the second one, or they could both be 4. It allows for more than one thing to happen. So this is not at all as easy as the first one I did, where I said where I could get both 4s. This is a little more work. So what I like to do for these, and what I think will be easier for you, is anytime you see this phrase, at least, you think, let's use the opposite. Let's use the complement rule. Okay? So what the complement rule says is, what if I look at the other, right? So let's look at the other option. What's the opposite of at least 1 4? It's neither 1 or 4s. Okay? So neither 1 is a 4. Well, I have a 5 out of 6 chance of that. Both times, so that gives me 25 out of 36. So of all the times that I could get a 4, 1 or more, 25 out of 36 times I don't get either. So what I'm going to do is subtract. So I say I take all of the probabilities, which would add to 1, and say 25 over 36 means neither 1 or 4s, which means the rest of them, 11 over 36, give me at least 1 4, so 1 or 2. How did it go from 1 minus 25 over 36 to 11 over 36? You have a couple ways you can do it. I know your favorite way would probably be throw it in your calculator. Absolutely fine. I put up a couple videos on my HCC that show you, hey, use your calculator to do this probability and just use the fraction button. Or if you want to go old school and do it by hand, which is my preference because I'm a mathematician, I remember that 1, I'm sorry I write really slow, is 36 over 36. I'm using the denominator I have in my fraction. So this 36 is why you chose this. And then I can have this like denominator of 36 for both of my terms. So that way when I subtract 25 from 36, I get 11. Okay, so let's move on. All right. So let's say Sam is taking a 5-question multiple choice test, and Sam didn't study. So he's going to have to guess on all the questions. Let's say there are 4 choices for each question, and let's find these probabilities. So let's A, find the probability he gets them all correct. And then B, find the probability he gets them all wrong. And then C, find the probability he gets at least, there's that phrase again, at least, so that's going to be important. Let's underline it, 1 correct. Okay. So even though this doesn't kind of look like it, I didn't say the word and when I gave you these problems, this definitely is an occurrence of and. Because what I'm looking at, he gets problem 1 right, and problem 2, and problem 3, and problem 4, and problem 5. So I look at this as having like 5 things to do. And what I'm trying to do is let Sam get these questions correct. So each time he guesses, he has a 1 out of 4 chances of guessing correctly. And that would be the same for all 5 questions. So if I multiply 1 over 4 5 times together, I get 1 over 1,024. Not looking too good for Sam. All right, see the flip side. Well, all right was only 1 out of 1,024. Let's look at the probability he gets them all wrong. He gets a big fat 0 on the test. So every time he guesses, he has a 3 out of 4 chance of guessing it wrong. So I multiply that 3 over 4 together 5 times, and it gives me 243 over 1,024. So it's a lot more probable that he gets them all wrong than if he gets them all right. Kind of in the middle there, I said in part C, what's the probability he gets at least one correct? Okay. Again, anytime I see at least, I want to do 1 minus the complement. So 1 is the easy part. I know to put 1 down. The complement is what's the opposite of getting at least 1 right? It's getting them all wrong. So you can see again, I've set us in the right direction. In part B, I had us figure out how to get them all wrong. So I just want to do 1 minus 243 over 1,024. Again, I showed you that what is 1? 1 is 1,024 over 1,024. And then I subtract the 243 over 1,024, and it gives me 781 over 1,024. Okay, so there's my option of getting at least 1 right. So that could be 1 right, 2 right, 3 right, 4 right, or all 5. So that's a big thing. We don't want to have to do C individually as all the different ways you can get at least 1 right. You want to do it using the complement rule. Okay, so let's stick with this idea of just moving on with our and let's say instead I moved on from taking a test to looking at people's cell phones. So let's say I had a group of 50 people, and I found out 28 of them have iPhones, 15 have Samsungs, and the rest have some other brand. So let's pick 2 of them at random and figure out the probability. A, they both have an iPhone. B, neither one of them have an iPhone. And C, at least one of them has an iPhone. Okay, so let's fill these in. Start with A. This one is a little different than our previous ones where I was looking at rolling a die or getting a test question correct, because those kind of started over each time, right? You answer a question for the test, I had a 1/4 chance of getting it right. I get to the next question, I start over, I have a 1 out of 4 chance of getting it right. Now that I have people, you'll see this little difference in how the answers come out. So let's start with our 50 people, and I'm trying to find the probability one of them has an iPhone. Well, that's 28 out of 50. I had all 50 people to start. 28 of them had iPhones, so I have 28 out of 50. After one of them has been selected, I don't have 50 people left. Now I have 49. And because that first person has an iPhone, then there's only 27 left that have an iPhone. So you do see this little difference when I've switched over to people or something that can't be repeated. Then I will see little differences in the next step. So remember back that definition at the beginning, probability of A and B, where I gave you that note that said the probability B is done with the assumption that A occurred. Well, here, that's where this comes into effect. I assume this happened. I pulled one of these 28 people, which leaves me with 27. So just be careful when you're using and to make sure you look at what scenario is going on. All right, I put those together, again, multiplication. So I have 756 over 2450, which gives me 30.9%. So let's go again. Neither have an iPhone. All right, so 28 have an iPhone, which means 22 do not. So 22 out of the 50 do not, and this right here should be a 4. Sorry about that. Let's type that. All right, so I had 22 out of 50 people do not have an iPhone. And then I picked once, and I have 21 people out of 49 people that do not have an iPhone. So that gives me a total of 462 over 2450, which is 18.9%. Okay. Last scenario, at least one of them has an iPhone. All right, so I keep pushing this point of at least because it's important. So at least one of them has an iPhone says do the opposite and subtract it from 1. Okay. So the complement of at least one iPhone is neither has an iPhone, again, which is what we did in B. So because I put these in percent, I just wanted to show you what a percent would look like. So from the 100% things, all the different possibilities of what could happen, 18.9% of them where they don't have an iPhone. So I do 100 minus 18.9, which is 81.1. So that 81.1 would consider they both have an iPhone, remember that 30.9 we had, or one of the two has an iPhone. So that's all incorporated into here. Okay. So let's have some U-tries. All right, so this one's a restaurant. And I tell you the number of people that came and then said they would recommend the restaurant, 37, would not recommend the restaurant, 18, and they're not really sure, 6 of them. So I want you to take this and look that I did tell you that 61 people who ate here, and decide if 2 people were selected at random, what's the probability they would both recommend the restaurant, they both would not recommend the restaurant, and then I want you to give it a try. Okay. So let's look at A. The probability they would both recommend the restaurant. So I had 37 people who would recommend the restaurant out of 61. Once I choose one of them, it leaves me with 36 people, and then I have 60 people. Because again, once I select someone, I need to just lower what's left. So that gave me 1,332 over 3660, which is 111 over 305. For part B, they both would not recommend the restaurant. Well, there were 18 people who wouldn't out of 61. Once I pick one of those, I don't have 18, now I have 17. And then from 60 people left, it says 51 over 610. Right, so let's try something similar. This one I said let's look at runners. And let's do runners by length of the race they ran, so 5K or 15K, and then whether they were female or male. So this, if you were to add it up, it would come out to 100 people, and they ran a race. You can see the categories again that I said, and I want you to think about selecting 2 people at random and then find the probability. A, they were both female. B, they both ran the 5K. C, at least one was a male. There's that at least again. And then D, both were male. Okay, so try this. Again, pause, come back. Really important that you do these you-tries. You're not going to know if you're getting it until you do it on your own. It always looks better when someone just reads it to you, or hopefully it does, but you really find out if you know it when you try it on your own. All right, let's see how you did. So let's go to A, both females. All right, so adding up the 28 and the 15, that gave me 43. So I had 43 females that ran these races out of 100. Once I pick one of them, now I have 42 left and 99 left. That gave me 1,806 over 9,900, or 301 over 1,650. Part B, they both ran the 15K. So then I look at 25 and 15 is 40. So I had 40 over 100 to start. Since I picked one, I'm at 39 over 99, which is 1,560 over 9,900, or I could reduce it to 26 over 165. Part C, here's that at least I keep talking about. Trickier. Since it says at least, I use the complement rule. So I do 1 minus the probability both are women, which again we did in part A, so usually I'm asking you these things that are kind of lumped up together. So I go back to 1 minus the 301 over 1650 I had at the beginning, which gives me 1,349 over 1,650. Okay, part D, both were male. Same, add up them in. 32 and 25 is 57. I have 57 over 100 times 56 over 99. 3,192 over 9,900, which reduces to 266 over 825. Right. Last example for this short video. This one I switched to basketball. So say we have this really good basketball player. He can make 85% of all free throw attempts. I think that's awesome because I probably could make like 0.85%. So let's check out what would happen if he threw it twice. Do we think he would get it 2 times in a row? Find that probability. Then we're going to say, well, let's let him have 3 shots. So let's see if he can get 3 in a row. And then let's look at the probability that he misses 3 shots in a row. What would that look like? All right, so do those. Give yourself, again, a couple of minutes to try these out, and then come back and check out with me. Let's see how you did. All right, so first, he gets 2 free throws. This is still my and, right? Even without the word and can happen, and that's important for you to realize. What are you doing? This is and. He gets the first one, and he gets the second one. That's 2 in a row. So I have 0.85 times 0.85, which is 0.7225. So I just wrote that as 72.25%. Okay. 3 in a row just means we're going to put one more 0.85 out there. So 0.85, 0.85, 0.85 gives me 0.6141, or 61.41%. And then lastly, if he misses, okay, here's the thought I need you to have with me. If there's an 85% chance that he gets a shot, what's the probability he misses? Well, it should be 15%, right? There's only 2 choices. He hits it or he misses it. So hit is 85, miss is 15. So if I'm going to have him miss 3 times in a row, it's 0.15, 0.15, 0.15, really, really small. It's 0.0038 or 0.38%.